We've been talking a lot about tangent lines lately, and I thought I would get you out of the standard type of problem where we give you a function and we ask you to find a tangent line at a specific point, but rather I have a geometry problem for you. So here's the problem. We want you to find the areas of the triangles enclosed by the axes and the line tangent to y is equal to 1 over x. So that's what I have graphed over here, and that is for x greater than 0. So why don't you pause the video and try to mess around with this problem a little bit and see what you find. All right, assuming that you've given it a go, let's first try to get some grips on what this problem is saying. It's saying, all right, we need to somehow find some triangles, and those triangles are going to be constructed by making a tangent line and figuring out where those tangent lines intersect the x and y axes. So let's see if we can visualize that. Let's drop down just a random point here, and we can call this, let's say, x naught, y naught. So x naught, y naught. Okay, and a tangent line to this point would look something like this. Let's see, something like this. Okay, so we have a tangent line now. And with this tangent line here, you can see that we have a triangle, that this triangle appears. We have a triangle now. We have a triangle. And again, we want to find the area of all of these triangles. So we can make a ton of different triangles, but let's just talk about this one for right now. So we want to find the area of that triangle. So we can call this, let's call this the base of the triangle, and let's call this the height of the triangle. So we know the area of a triangle. It is 1/2 base times height. 1/2 base times height. And really what we need to do is figure out what the base and the height are. And in order to do that, you can see that we need to get a grip on what this tangent line is. We need to come up with a tangent line. So in order to do that, let's go over how to construct a general tangent line. So we're going to make a general tangent line. General tangent line. Tangent line. And we're going to construct it at x naught, y naught. So it's going to be at x naught, y naught. Okay. So, we've already learned about this, but really a tangent line is, we can just start off by describing the equation for a line in point slope form. So we can say that y minus y naught is equal to m, that's the slope, times x minus x naught. So that's just a general equation for a line in point slope form. And really this should be review, but m, the slope here, when we're talking about a tangent line, the only thing special about it is that our slope is the derivative at that point. So it's going to be the derivative at x naught. And in order to start filling this in, I'm just going to quick name some notation. So we are going to let y be equal to f of x, and we are going to then, we already said that the slope is going to be f prime of x naught. And then lastly here, we can say that y naught is equal to f of x naught. So just some quick notation. So let's go in and fill in some of this notation. So we have y minus f of x naught. F of x naught is equal to, we said our slope is going to be f prime of x naught, times x minus x naught. So now the only thing that we really need to find, that we can't easily look at and see, is this derivative. We need to figure out what the derivative of f at x naught is. So let's do that. Let's do that over here. We're going to find the derivative, so f prime of x naught, and we're going to use the definition of the derivative. So that is the limit as x goes to x naught of f of x minus f of x naught all over x minus x naught. Again, just the definition of the derivative, and then let's apply it to our function. So we can fill this in. We have the limit as x goes to x naught of f of x, which is 1 over x. So we can fill this in, 1 over x minus f of x naught, that is 1 over x naught. And all of this is still over x minus x naught. Okay, and now all we need to do is kind of simplify this numerator here, and then we can end up taking the limit. So let's get some common denominators, and we're going to be left in the numerator with x naught minus x over x times x naught, and then we still have this denominator here. And again, we're still taking the limit, but to save some time, I'll just put those 2 marks there. So in order to so we can evaluate this limit, let's take this denominator out and also take out a -1, because that seems like we would then be able to cancel the x minus x naughts. So we get the following: the limit as x goes to x naught of, we said we were going to pull out this -1, and we would still have this x minus x naught. And then we are left with, in this numerator here, x minus x naught, that's why we pulled out the -1, over x times x naught. And now we can evaluate this limit. And these cancel. So evaluating this limit, we get the limit, I want that in purple. We want the limit as x goes to x naught of 1 over x times x naught. And then evaluating this, again, this is just going to be, our derivative is -1 over x naught squared. That's our derivative, and we can plug this back into our general tangent line and keep working on it. So we have y minus, and why don't we just fill in what f of x naught is? F of x naught is 1 over x naught, so we have 1 over x naught, and that is equal to, and we found our derivative to be, -1 over x naught squared. And then we are still multiplying that by x minus x naught. Now all we need to do is distribute this to this term here, and we can add 1 over x naught to this side, and we will get the following. We have y is equal to, on this right-hand side, -1 over x naught squared times x. And then these will become positive, so we have plus 1 over x naught, and then adding this 1 over x naught to this side. And then finally, we can simplify this one step more, so we have -1 over x naught squared times x, and then plus 2 over x naught, 2 over x naught. So this is what we find our general tangent line to be. And again, you give me any point on this curve here, and I'll be able to give you a tangent line for it. That is what it's saying. So now that we have this, we can come back to our problem. Again, we want to find the area of all of these triangles. So we need to find the base and the height. And you can see this general tangent line that we just constructed, that the base can be found when we find the x-intercept, and the height can be found under the y-intercept of this tangent line. So let's first find the base, and that's going to be at our x-intercept, and we are going to find the base of our triangle. The x-intercept, we're going to let y be equal to 0 for this general tangent line. So let's plug in y is equal to 0 at that general tangent line, and we get this is equal to -1 over x naught squared times x plus 2 over x naught. Okay, and then all we need to do is solve for x. So we can add this term over, and I'm just going to keep it in orange now. So we have 1 over x naught squared times x, and this is equal to 2 over x naught. And then we multiply by x naught squared on both sides, and we find that x is equal to 2 times x naught. And that is our base of our triangle. So we got one down, one more to go. We just need to get our height. And we said the height was going to be the y-intercept. So we're going to let now x be equal to 0 in our general tangent line to find the height. So let's find the y-intercept now. Y-intercept, and that's going to be our height. Our height. Okay. And again, we want to let x be now equal to 0. So we have y is equal to -1 over x naught squared. And this is going to be multiplied by 0 now, plus 2 over x naught. So this will be 0, and we find that our height is equal to, when y is equal to 2 over x naught. That is our height. That is our height. So now we have everything that we need to find the area of all of these triangles here. And I'm going to bring this calculation down here, just grab some more space. So we find our area is equal to 1/2 times our base, which we found to be 2 times x naught, and then times our height, which is 2 over x naught. 2 over x naught. This is getting pretty exciting. So again, we see that x naughts cancel, and then we have 2 times 2 is 4 divided by 2. So we find this really cool answer that the area of all of these triangles is 2. Which, come on, that is a pretty cool answer here, because again, that's saying that whether we make a tangent line here or we make a tangent line up here, all of the triangles that we can make from tangent lines intersecting the x and the y axes, all of their areas will have the area of 2. All of the area of these triangles will have the area of 2, which is pretty cool. And real quick, before we leave, just notice this. Just notice this. The only part of this problem here that was calculus-based was figuring out this tangent line. The rest of it was just a geometry problem. So that is pretty cool.